Introducing a dramatic advance in technology for CNC router production that sets a new pattern for efficiency. The Carter Flip Pod System. It's a revolutionary new concept in piece part work holding for CNC production that cuts costs, reduces setup time, and increases production output for industries that do repeat cutting and drilling of wood, plastic, or non-ferrous metal parts. The Carter Flip Pod vacuum piece part holding system directs vacuum power exactly where it's needed to hold parts in place for machine processing. The Carter Flip Pod system is based on a grid of cavities fitted into the surface on which parts are placed for processing. By controlling the air passing through these cavities, vacuum can be maintained precisely in any areas desired without using time-wasting spoil boards or other methods. This control is accomplished with the special pod elements shown here that fit securely into the gridded surface known as the pod panel. The system is made up of these two primary components. First, the flip pod elements supplied by Carter, and secondly, the pod panel produced by the customer. Finishing the pod panel at the customer's site assures utmost accuracy, since it is customized precisely to meet the capabilities of the equipment and the demands of the task. Pod panels can be designed to fit the precise task demanded. Pod openings generally are spaced 4 inches or more apart on center from each other. Pod panels can be laid out in almost any design, in diamond, linear, or circular patterns. Pods are precision-molded circular units constructed of plastic and lie flush to the panel surface, nested in cavities cut into the pod panel. Each pod has a diameter of 3.5 inches and is equipped with a filter element, ball check, and extension cup. In operation, pods are placed in either the off or on positions, depending on whether suction is required at a given point. Control of the vacuum area can be maintained with total flexibility, simply by repositioning or flipping individual pods. A simple flip into the up position activates each pod. Pods turn on automatically to allow vacuum holding at that specific point, when the operator inverts each pod in the machine seating area of the panel. Pods in the on position lift the workpiece 1 3/32 of an inch above the panel surface to allow machining on all edges and upper face of the part. All parts of the system self-store or nest within the system itself, facilitating fast changeover from one operation to the next. The system is modular and can be adapted to most CNC router machine vacuum tables currently manufactured, depending on configuration and vacuum pump capacity. Please refer to product literature for specific technical requirements. Flip pod units do not limit or restrict X, Y, or Z-axis movements of CNC router machining systems. Reliability is enhanced, since there are no moving parts to wear or replace. The material used in the pod system has been carefully selected to prevent damage to cutter heads should they accidentally come into contact. No complex instructions or extensive training are involved in getting the system fully operational. Installation of the pod panel does not interfere with the use of small spoil boards for specialized applications. These boards simply are placed on top of the pod panel, using the pod cavities for positive location. Fixed and retractable locator pods accurately position material for processing. Locator pods, offered as an integral part of the Carter Flip Pod system, enable the user to position material accurately for processing. Locator pods are available in both fixed and retractable versions. either of which fit in any pod cavity. Each fixed locator pod includes a body, pin, and spacer disc. Different sized discs are available to allow parts to be positioned different distances from the center line of the pod cavity in which the locator is placed. This type of locator is for use where greater positioning accuracy is needed and where no cutting is being done to the edges of the part, which rests against the locators. For edge cutting, spring-loaded retractable pods pull back to provide clearance for the cutting tool path when the vacuum is activated. Supporting smaller parts exactly at the edge of the cut can be critical. Carter's half pods are available as an accessory for such applications. Carter's transfer pods are another useful accessory. Placed in the appropriate location, they elevate heavy materials slightly above the flip pods to facilitate movement of the part into the proper position. The Carter flip pod system can be adapted to most CNC routers currently available and has also been successfully used with a variety of point-to-point boring machines. Implementation of a system is very straightforward. A complete system can be installed and operational in less than a day. The system's primary advantage is that it eliminates the need for expensive, dedicated fixturing for each part. It is no longer necessary to incur the substantial labor and machine costs associated with the design and production of large numbers of spoil boards. The flip pod system also frees up the space and manpower that otherwise would be required to store those spoil boards. These cost savings alone result in a very quick payback of the initial investment in the flip pod system. Equally, if not more important, the machine setup times associated with changeover between different parts is dramatically reduced. This allows you to be more cost competitive, which can be especially critical for short production runs and prototyping work. These factors combined will result in increased production efficiency and a greater return on your CNC router investment dollars. It's an advance in technology that has found immediate acceptance with industry. The new pattern of progress in CNC production, the Carter Flip Pod System. To find out more about this remarkable development, write or call Carter Products today. We've been providing better ways of doing things in the woodworking industry for over half a century. The Carter Flip Pod system can work to streamline your CNC router operations and add time-saving efficiencies. This portion of the videotape is designed to help you get started right to capitalize on the substantial advantages it brings with it. The first step to gaining full potential from the Carter Flip Pod system in CNC operations is constructing the pod panel properly. Here are some fundamental points to keep in mind that will help ensure success. The most basic consideration is pod panel material. The choice here is critical. The pod panel must be fabricated from material that has adequate structural strength, easy machinability, good dimensional stability, and high resistance to the flow of air through the material itself. After intensive evaluation, it's our judgment that UHMW, one of the more reasonably priced plastics, or an alternative non-porous material with these same qualities, matches the required standards best and is the recommended choice for use in constructing the pod panels. The minimum workable panel thickness is 1 3/4 inch. Thinner panels will not provide the necessary space to mount the pods. Thicker panels will unnecessarily restrict the Z-axis clearance. The pod panel will be attached to a user-supplied router machine bed or table substrate and powered by a user-supplied vacuum pump. This substrate should be a flat plate of sufficient thickness with adequate underlying support to withstand the loads expected in service without flexing or movement. As noted earlier, the top surface of the substrate must be of material that will not permit air to pass through it. That point is crucial to success. For example, if particle board is used as the substrate material, it must have a sheet of high-pressure laminate, the kind usually applied to countertops, mounted on the top surface before the flip pod panel is put in place. Most routers have machined beds with air channels, which can be matched to conform to the underside of the pod panel. For maximum accuracy, it is strongly suggested that the router itself be used to machine the top and bottom surface of the pod panel material. Before the process of machining the pod cavities is undertaken, an appropriate pod panel layout and distribution must be designed. A typical uniform pattern might be spaced 4 inches or more apart on center from each other. It should be noted, however, that the user can create any pod panel design in linear, circular, or diamond pattern that is most applicable to the parts being processed. In short, the pod panel layout should be designed to fit the task. The vacuum pump is, of course, a paramount factor involved in the task. To get the desired result, it is vital that your vacuum pump operates within certain minimum performance guidelines. For specifics in this regard, please refer to the Technical Requirements section of the sales brochure. The plumbing from the vacuum pump to the machine bed of the router also is important to successful operation of the flip pod system. For example, it is possible to have an adequate pump online, yet find that plumbing components such as air lines and fittings are restrictive. The result of this is that even though the vacuum pump itself is adequate for the system, vacuum reaching the pod panel is insufficient. Now let's explore how to make the pod panel. Use a straight 2-flute cutter, typically 3/4 or 1 inch in size, to create the initial pod cavity in the dimensions shown on this drawing. Next, fashion the groove for the upper gasket by making 2 passes with a 3/16 inch cutter. After machining the upper groove and wall of the pod cavity, produce a single hole 3/16 inch in diameter in the bottom center of each pod cavity, and a recess 1 1/8 inch diameter surrounding the center hole. The recess area is 0.08 inch lower than the rest of the bottom surface. As shown in this drawing, in each recess you will place one of the center gaskets provided with the extension cups. Remove the paper from the self-adhesive back of the gasket and press it firmly into the recess, making sure that its edge fits into the recess all the way around, so that the top surface of the gasket is completely flat. Around the outer edge of each pod cavity is a groove into which you will place a large gasket, as you see in this drawing. This must be done with care, making sure it fits into the groove without any twisting or kinking. You may use one of the pods held with the large flange side down to help push the gasket down completely into the groove to make sure it is fully seated. Next, the pods themselves are prepared by firmly pressing an extension cup into the groove in the narrow end of the pod, so that the rubber ring on the back of the extension cup fully seats into the groove, and the curved lip of the cup points out away from the pod. Once all the pods are ready, place them cup side down into the cavities of the panel. After all cavities are filled, apply vacuum to the system and check for and correct any leaks. Each pod that is in the down or off position traps the vacuum and prevents airflow through that cavity. To use the system, simply turn over the pods located under the part or parts to be machined. Pods turned into the upright position will support the workpiece above the pod panel, allowing easy access to the edge of the part, and vacuum will act through the cavity and pod to hold the part tightly against the extension cup on the top of the pod. Machining a different part is simply a matter of reversing pods in the appropriate areas as required to match the new part. In order to flip pods easily from the inactive or off position to the active or on position, you may wish to create finger holes. You can do this by cutting across all the centers of the pods in one direction. Make sure that the depth of such finger channels is less than 0.14 inches from the upper surface of the pod panel. That's important. To get maximum advantage from the system in operation, there are some factors to keep in mind regarding wear and maintenance. Here's a summary. As you know, each pod contains a small check ball, a covering filter, and an extension cup. When using the pod system, check periodically to make sure that these three elements, as well as the large pod panel, remain intact and in place. Any damaged or missing parts should be replaced immediately. Replacement parts are available separately from Carter. If the interior of the pod needs cleaning, simply detach the extension cups and remove the filter by pushing gently with the blunt end of a pencil or similar object through the small hole in the narrow end of the pod. After the pod is cleaned, make sure that the check ball is reinserted into the central cylindrical cavity again, before gently pushing the filter back into place and reinstalling the extension cups. The filter should be installed with the smooth side out. How frequently cleaning is required will depend on the quality of your dust collection system. As you might expect, some wear can be anticipated on the extension cup and the large gasket after usage, just like the tires wear out on your car as the miles mount. It may in some cases be necessary to replace either of these components from time to time. And of course, routine housekeeping is necessary to help ensure long, efficient operation. The surface of the pod panel should be maintained as dust-free as possible. That will help keep pod components tidy as well. We recommend that any cleaning or removal of scrap from the pod panel surface be accomplished while the part is still held in place by the vacuum. Experience has shown this simple process can be significant in the optimum performance of your system. We hope this presentation has covered the preparation and care required to help you get maximum efficiency from the Carter Flip Pod system in your operation.